Thank you for tuning back into the Automation Podcast. My name is Shawn Tierney from Insights, and today on the show we have a special treat. We have Mark Berger back on from Siemens to bring us up to speed on SIRIUS ACT. He's going to tell us all about the product, and then we're even going to do a small demo and take a look at it working live. So with that said, let's go ahead and jump into this episode with Mark Berger from Siemens and learn all about their push buttons on Profinet. Mark, it's been a while since you've been on the show. Thank you for coming back on and agreeing to talk about this.
Oh, thank you so much. I truly appreciate you letting me be on. I appreciate your channel and I enjoy watching it, and I'm excited to show you some of this great technology. So I've got the PowerPoint up here. We'll just do a simple PowerPoint to kind of give you an overview, and then we'll dive into the hardware.
Appreciate it. Thank you.
No problem. So as we stated, the SIRIUS ACT over Profinet. Let me emphasize that the actuators, the push buttons, the e-stops, the selector switches, they are all standard when you use these. So if you have those on the shelf, the only thing that Profinet does is that it adds, removes the normal contact blocks and adds the Profinet terminal blocks on the back. So all the actuators that we're showing are just standard actuators for the 22 millimeter push button line. So easy to use, modern design, performance in action, and extremely rugged and flexible. The 22 millimeter is out of the box IP69K, which for those who are maybe in the food and beverage verticals would understand what that is. And that's for direct hose down, wash down, able to handle a high pressure washing and not able to leak past the actuator into the panel. So IP69K is a great place for dust and wash down and hosing and where you're having rain and so forth, to be able to protect for a keep of any water passing into the panel. So introduction wise, it's the Profinet push buttons for us. It is again the same actuators, the same connections and so forth, but what we're going to exchange is the terminal blocks for it. So on there I stated it's IP69K is standard. You don't need any extra covers for it or anything to fulfill that requirement, but it's insensitive to dust and oil and caustic solutions, like citric acid, where you're hosing down some stainless steel parts and so forth. Now, what we have here is changing out the terminal blocks that have wiring. So usually on a push button, you have two wires coming in, and then you have, for illuminated, you have two wires coming in and so forth and going out. And after you have 20 or 30 push buttons or 10 or 15 push buttons, you've got a substantial little bit of wiring or cabling that will be passing from the door over into the main cabinet of your control cabinet. What we are going to do with Profinet push buttons is we're going to eliminate all that wiring, and then in addition, eliminate the input and output cards that you will need for your PLC, and take it down to a Ethernet cable, an RJ45 cable, and then down to a 24 volts. And that's all that will pass from the cabinet onto the door where you're mounting your push buttons. So huge safe and cost of wires. We're reducing all the wire outlay. And, back in the day when I built panels, it was an art how you got all the wires all nice and pretty and got them laid out and wire tied them down and so forth, and just made it a piece of art on the back side. And then it was all done. You got it all wired. And then, of course, there was somebody that said, hey, we forgot to add another selector switch. So you had to go back and cut all that stuff and redo the whole layout and so forth. So with Profinet, it's extremely flexible and easily to adapt to if you need something more, because you're not taking all that wiring back to the panel, passing it across the hinge of the door and so forth. It is also with a safety PLC. You do have ProfiSafe, so we can do e-stops on the door, as you can see here, the picture. But then we can do non-safe applications also. So today we'll be just doing some non-safe applications. And then the communications, again, is Profinet. But then also just to touch real quick, we do have it on IO-Link and on Aussie with our push buttons. So what is SIRIUS ACT with Profinet? There we go. So what you have is the first block or interface module that you put on the back of your push button. That's where the Ethernet is plugged into and your 24 volts is plugged into. And then after that, subsequently, then the push buttons that you have is that you have what we call a terminal module. And in between the interface module to a terminal module, or from terminal module to terminal module, you can go up to 1 meter of cabling, and it's a ribbon cable, and we'll show that here shortly. And then if you have we can do up to 20 push buttons, terminal modules, with a total of 21 push buttons. And then so from the first interface module all the way to the last push button, you can go up to 10 meters. And then again, 24 volt power supply for it. And we have, again, as I stated, a non-safe, talking just Profinet, and then the safety version, talking ProfiSafe on Profinet. So SIRIUS ACT, we can go up on the safety up to SIL 3 and performance level E as an echo. We have, again, the standard interface module without safety. You have the PLC, the interface module, and then the subsequent terminal modules for it. And then the cabling that goes from the interface module to out to the terminal modules is a simple ribbon cable that comes into the back of the terminal modules. The only tool that you need is just a screwdriver, and you push it into the terminal module, push down. It uses vampire connections, insulation displacement vampire connections, and you push it down in. There's no stripping of the wires. There's no mix up. The indicator you can see on the wires here in a minute will show you that there's a little red line that shows you which way it enters into the terminal. And then that's it. It's very straightforward. It's very simple with tools. And as I stated, it's just like a normal push button that you'd put on, but then we're going to remove the contact block and add the terminal module or the interface module in the place of the contact block. Just to emphasize again, we can do Profinet or ProfiSafe on with a safety PLC and a safety controller. And we can give you all the safety requirements for either the ISO or the IEC specifications for safety out there in the field. Here's some of the part numbers. First one, of course, is the interface module, and that has the ability to do ProfiSafe. It has also additionally 4 digital inputs, 1 digital output, and then 1 analog input. And we'll talk about that a little bit more just in a few minutes. And then the non-safe version, 24 volts. You have 2 versions of this one with just a standard 24 volts input. But then there's an additional one that has the 4 digital in, 1 digital out, and 1 analog in. So there's 2 different part numbers. One where you don't need the additional digital inputs and outputs and analog, and then the part number with the additional inputs and outputs. But the safety one there's no other version, just the one. Then you have what we call the terminal modules. And there's 3 versions. One terminal module is just the command module only. It's mounted with 2 mechanical signaling blocks to signal. So you have 2 contact blocks built in. Then you have one that's a terminal module with the command, the terminal blocks, and then also an integrated LED. And then you can put what color you want the LED to be. And you can see there the part number changed for red, blue, amber, so on. And then you have just an LED module, to where it's no contactors, it's just LED. And I think with our demo we're going to show today, we're just going to show the contact block and LED module and only the LED module today. There's some other accessories with the safety. There's a memory module to where all the configurations are put into the memory module, and something happens to that interface module. Everything's put in there, the IP address, the configuration and everything. If something gets broke and so forth, or you have to replace it, you pull the memory module out, put the new terminal or interface module in, plug in the memory module, cycle the power, and it's up and running. All the configurations, the IP address, everything's already there. And then on the interface module, it does not come with an LED, so you're required to buy this LED right here if you need it for it, and that's what you use for the interface module. And then, of course, the ribbon cable that goes between the interface module to the terminal block, or terminal module and so forth, come in 5-meter length and 10-meter length. Okay, so what's it provide for you? Well, the benefits are, I'll be very blunt. If it's just 1 or 2 buttons on a panel, it won't be that cost effective. Yes, we're reducing the IO inputs and outputs, but for the savings is not the best. Now, when you get up to about 3 or 4 push buttons, then that cost saving is very realized. Now, when you go up to 20 push buttons, yes, you're saving a lot of money, especially in the IO cards that you're not going to be required to have. And then, of course, all the wiring and the labor, getting it all wired up and doing all the loop checks to make sure that when you push this button, it's wired into the right terminal block on the IO card, so on and so forth. So about the break is about 2 to 3 push buttons to where it will become very cost effective for you to use it. But like I said yesterday, without Profinet push buttons, it was all the wiring you brought across and putting them into all your IO cards and so forth. And now with Profinet push buttons, all that goes away, and all you're bringing across is an Ethernet cable and 24 volts positive and 24 volts negative across that hinge into the door. And that's it. Okay, and then emphasizing again, we can do Profi Safe, and those push buttons and e-stops. The e-stop can be part of your safety circuit and give you the safety levels that are required from either SIL and or performance level safeties, depending on the specification, IEC or ISO that you're following within your plant. Okay, and then hardware configuration. Now this is where we step into reduction of engineering and helping you guys get going quicker and making sure engineering is done properly. Back in the day, we'd wire up all the wires coming from the push buttons, a selector switch, a start button, stop button, indicator lights, and so forth. And all those wires sometimes just, what we're working with, all the wires look the same. You've put labels on them. You may have labeled it wrong, and you wire it into an input card or an output card. So there's some time where you're over there doing some loop checks where you're trying to say, yes, that's coming into input byte dot bit, and that should be the selector switch. Well, with the Profinet push buttons, we're able to not have to worry about that, and we're going to demonstrate that just here in a minute. But you also have a full lineup of the push buttons coming into Portal so that you can see the lineup and verify that it is the parts that you want. In TI Portal, you can see that, of course, the first button is the interface module, and then sequentially is the terminal modules that have either just contactors, LED and contactors, or just LEDs. And we'll show that just here momentarily. But it's all integrated into TIA Portal. It has a visual representation of all the push buttons, and it's simple and fast to configure. We'll show you that here in just a moment. And there's no addressing for it. So some of the stuff that you have out there, you have addressing, making sure what the address is right, and so on. This is a standardized data management, and it's extremely time saving and engineering saving for the user.
Well, let me ask you a question about that. If with no addressing, do the items show up in the order that they're wired? In other words, you're daisy chasing you're going cable to cable from device to device. Is that the order that they show up?
That's exactly right.
Okay.
So if you don't know which ones are what, you just literally run your hand from the interface module, follow that cable, and the next one that will be visually saw in Portal will be the one that it lands on first.
Perfect.
And then there's a cable that leaves that one and goes into the next one, daisy chained. And then that's what will be represented in that lineup. And here in just a minute, we'll show that. All right. Thank you for that question. Okay, now, once I got it wired up, how do I know that I got it wired properly? And we're going to show that here in just a minute. But just graphically wise, you have the ability to see if it is all wired up. You do not need to plug it into the PLC. All it needs is 24 volts. The PLC can come later and plugging it in later and so forth. There's no programming. This all comes out of the box. So once you plug it in, if all on the back side, looking at the terminal blocks and the daisy chain ribbon cable, if it's all green, you wired it up properly and it's working properly. But then if you see a red light flashing, either at the terminal module, because that will bubble up to the terminal module. So if you have a problem somewhere, the interface module, if you have some problem with the terminal modules, a push button like number 2 or 3 or 4, it will bubble up into the interface module to let it know, hey, we got a problem. Can you look to see where it's at? And as you see here, we have maybe a device that's defective. And so it bubbles up into the interface module to let you know. And a red light lets you know that we have maybe a defective module, something hammered it pretty hard, or it may have been miswired. Then the second one down below, we've got a wiring error to where you don't have the green lights on the back and everybody else's, there's no green light shown. That means you have a wiring error. Or if everything works great, it's green lights across. But then the next level of this is my push button working? So then you will push or actuate the push button or actuate the selector switch, and the green light will flash to let you know that terminal module or interface module is working properly. And we've done our loop checks right there before we've even plugged it into the PLC or your programmer has come out and sat down and worked with it. We can prove that panel is ready to roll and ready to go. And you can set it aside. And if you got 4 or 5 of the same panel, you can build them all up, power it up, verify that it's all green lights across the board. It is great. Set it down, build up another one, and go on from there. So it shows you fast fault detection without any additional equipment or additional people to come in and help you show you that. When we used to do loop checks, usually had somebody push the button, then yell at the programmer, hey, is this coming in at I0.0? Yeah, I see it. Okay. Or then he push another one. Hey, is this coming in on I0.1? No, it's coming in on I0.3. So there was that 2 people and then more time to do that loop check or the ring out, as some people have called it. So in this case, you don't need to do that. And you'll see why here in just a minute. And then again, if we do have an interface module that maybe it got short circuited or something hit it, you just pull the EEPROM out, plug it into the new one, bring in the ribbon cable and cycle the power, and you're up and running. All right. And then this is just some of the handling options of how it handles the data with the projects and so forth, with basic setups, options that you can be handling with this, filling bottles. What we want to make sure to understand is that if maybe push buttons, you can pick push buttons to work with whatever project you want it to do. So if you have 6 push buttons out there, 2 of them are working on one bottle filling, and then the rest of them are working on the labeling, you can separate those push buttons. Even though that they're all tied together via Profinet, you can use them in different applications across your machine.
You're saying if I have multiple CPUs, I could have some buttons in light work with CPU 1, PLC 1, and some work with PLC 2?
Yep, there's handling there. There's programming in the back side that needs to be done. But yes, that can happen. Yep.
Oh, all right.
So conclusion, integrated into TI Portal. We're going to show that here in a minute. It's a universal system, high flexibility with your digital in, digital outs, analogs, quick and easy installation, one man, one hand, no special tooling, and then substantially reducing of wiring and labor to get it going. And then again, integrated safety if required for your time. So with that, let's switch over to TI Portal. So I've already got a project started. I just called it Project 3. I've already got a PLC. I've got our new S7 1200 G2 already in. And then what I'm going to do is I've already built up the panel. And Shawn, if you want to show your panel right here.
Yeah, let me go ahead and switch the camera over to mine. And so now everybody's seeing my overhead. Now, do you want me to turn it on at this point? It's off.
Yeah, okay, let's do it.
I'm going to turn it on. And all the lights came on. So we have some push buttons and pilot lights here, but the push buttons are illuminated. And now they've all gone off. Do you want me to show the back now?
Yep. So what we did there is that we just showed that the LEDs are all working. And that's at the initial powering up of the 24 volts. Now we're going to switch over and, open up the cabinet and look inside. And now we're looking on the back side. And if you remember in the PowerPoint, I said we'd have all green lights, that everything's wired properly. And as you look, all the terminal modules all have green lights. And so that means that's all been wired properly. If you notice, you see a little red stripe on the ribbon cable.
Mhm.
That's indication, to show you that. And then if you look on the out, on the interface module, Shawn, it says out right there at the bottom.
Yep.
There's a little dot, and that dot means that's where the red stripe goes, coming out. So that little dot means that's where the red stripe comes. Yep, right there. And that's how it comes out. And then if you look just to the left a little bit, there's another in, and there'd be a red dot underneath that ribbon cable showing you how the red goes into it. Notice that everything's clear, so you can see that the wire gets engaged properly all the way in. And then all you do is take a screwdriver and push down, and then the vamp comes in, the insulation displacement comes in, and makes the connections for you. So there's no cable stripping tools or anything special for doing that. Another item, just while we're looking, if you look in the bottom left-hand corner of that terminal module, you see kind of a T and then a circle and then another T. That's an indicator to let you know that that's two contactors and an LED that you have on the back side.
We're talking about right here?
Yep, right there. Okay. So that's an indicator to tell you what type of terminal block it is, a terminal block that it is. That's two contactors and LED. And then if you look at one in the bottom left-hand corner, there's just a circle. That means you just have an LED. So you have some indicators to show you what you're looking at and so forth. So today we're just using the two LED only, and then we're doing the contactor and LED combination. I don't have one there on your demo that's just the contactor. So
now you were telling me about these earlier.
Yeah. So so if you look there on that second row of the terminal blocks, you have a UV and an AI. And I'll show that in the schematic here in just a little bit. But there, that is a 10-volt output. If you put a 250 ohm or 250 k ohm potentiometer and then bring that signal back into AI, you have an analog set point that comes in for it that will automatically be scaled 0 to 1000 count or 0 to 10 volts. Mm-hmm. And then you can use that for a speed reference for a VFD. And it's already there. All you have to do, you don't have to scale it or anything. You can put it towards, 0 to 1000 count means 0 to 500 PSI or 0 to 100 feet per second on a conveyor belt. And I'm just pulling numbers out, but that's the only real scaling you have to do. So it would be a 0 to 1000 count is what you'll see instead of and then you got 4 digital ins that you can use and then a 1 digital out. Now the 4, I kind of inquired why just 4, but let's say that you have a 4-position joystick. You could wire all 4 positions into that interface module. And then the output could be something else for a local horn that you want or something to that case with it. So in addition to the push buttons, you also have a small distribution IO block right there in your panel.
Which is cool. Yeah, I mean, maybe, like you said, maybe you have something else on the panel that doesn't fit in with this line of push buttons and pilot lights, like a joystick, right? And that makes a lot of sense. You were saying too, if I push the button, I can test to see if it's working.
Correct. So if you, go right ahead.
I'm pushing that middle one right there. You can see it blinking now.
And that tells you that the contacts have been made. And it's telling you that the contacts work properly.
And now I'm pushing the one below it. So that shows me that everything's working. The contacts are working and we're good to go.
Yep, everything's done. We've done the loop checks. We know that this is ready to be plugged into the PLC and handed off to whomever is going to be programming the PLC and bring it in, and which means that we'll go to the next step into TI Portal.
Yeah, let me switch back to you, and we're seeing your TI Portal now.
Awesome. Okay, so I've got the PLC. I've plugged it in to if I needed an Ethernet switch, or I've plugged it directly into the PLC. Now, I have just built up that panel. I haven't had anything done with it for an IP address because it is a TCP IP protocol. So we need to do a IP address, but it's on Profinet. And then I'm going to come here to online access, and I want to see that I can see it out there that I'm talking to it. So I'm going to do update accessible devices. It's going to reach out via my Ethernet port on my laptop. And then there's our G2 PLC and its IP address. So that's that guy right here. Mm-hmm. And then I have something out there called accessible devices. And then this is its MAC address. So I just have those 2 items on the network, but you could have multiples. As you know, with TI Portal, we can put an entire machine in one project. So I come here and drop that down, and I go to online diagnostics. I go online with it, but I don't have really a lot here to tell me what's going on or anything yet. But I come here and I say assign IP address, and I go 192. 168.0.0.0 and 0.10.0, and then our usual 255, 255, 255, and then I say assign IP address. Give it a second. It's going to go out and tell it, okay, you're it. Now I want to see if it took, and you look right there, it took. And I'm kind of anal, so I kind of do it again just to verify. Yep, everything's done. It's got an IP address. Now I'm going to come up, and I'm going to go to my project. And I'm going to switch this to new network view. Here's my PLC. I'm going to highlight my project. Now, there's 2 ways I can go about it. And I'm sure, Shawn, you've learned that Siemens allows you to kind of do it multiple ways. I could come in here and go into my field devices, and I could come into my commanding and interface modules, and I start building my push button station. But we're going to be a little ooh and ah today. We're going to highlight the project. I'm going to go to online, and I'm going to come down here to hardware detection and do Profinet devices from network. Brings up this screen to say, hey, I want you to go out and search for Profinet industrial Ethernet, come out via my NIC card from my laptop, and I want you to start search.
For those of you who watched my previous episodes doing the ET200IO, this is exactly the same process we used for that.
Yep. And I found something out there that I know I gave the IP address, but it doesn't have a Profinet name yet. So that's okay. I got the IP address. We'll worry about the Profinet name. So we'll check mark this. And this could be multiple items. Mm-hmm. Okay. So now add device.
And this is the sweet part.
And right here, it's done. It went out, interrogated the interface module and said, okay, are you there? Yep, I'm here. Here's my IP address. And it also shared with it all of... Come in here, double click on it now.
The real time saver, yep.
Yep, and then now here's all the push buttons in your thing. And let me zoom that out. It's at 200%. Let's go out to 100. And now it already interrogated the interface module and all the terminal modules to tell me what's in my demo. Yep. And again, as you stated in your question, is how do I know which one's the next one? You just follow the ribbon cable, and then it brings you so forth and so on. So that's done. We're good. I'm going to go back to my network view. And I'm going to say, hey, I want you to communicate via Profinet to there, which I'm done. And then it also gives you, here's the PLC that you're going to do. Because, if we have a big project, we may have 4 or 5 of these stations, and you want to know which PLC's the primary PLC on it. Mm-hmm. And then we've done that. I'm going to quickly just do a quick compile. And next, I'm going to come here. I'm going to click here. Now, I could just do download and let the Profinet name, which is here, go into it. But I'm going to right click, and I'm going to say assign device name and say update list. It's going to go interrogate the network. Takes a second. No device name assigned, no Profinet name. So this is how we do that time determinism with Profinet. So I'm going to highlight it, and I say assign the name. And it's done. Close. So now it has a Profinet name and IP address. So now I'm able to go in here and hit download. And load. And we're going to stop because we are adding hardware. So we are putting the CPU in stop. And hit finish. Now I always make sure I'm starting the CPU back up and then hit finish. And then I'm going to go online, go over here and show network view and go online. And I got green balls and green check marks all over the board. So I'm excited. This works out. Everything's done. But now, what about the I/O? So now your programmer is already talking to it, but now I need to know what the inputs and outputs are. So go back offline, double click here, and then I'm going to just quickly look at a couple things. The interface modules I/O tags are in a different spot than the terminal modules. So just a little note, it's right here. If you double click on integrated iLED, you click here and then go to properties and say I/O tags. There it lists all of the inputs and outputs. So it comes here. But if I do a terminal module, click here, then once you just click on it in general, it's right here in the I/O addressing. There's where it starts, the bytes, but then I come here to tags, and then here's the listing. So the program's automatically already allocated the byte and the bit for each of these guys. So if I click there, click there, there's it there, onward and upward. Now notice that the byte, so if I click on position 4, it is 3. So it's one less because the base 0 versus here it's 5. Just give me a little bit of a, so if you look in here, that starts at I 4.0. I 4.0. So, okay. So that's there. So I'm going to come here. I'm going to go to the selector switch for this, and I've called it SS1, and that's input 2.0. And then I'm going to click here, and I'm going to call this green push button. Notice there's 2 inputs because I have one contactor here, one contactor there, and I 3.0 and I 3.1. So then what I'm going to do is that I'm going to go over here to the PLC, and I'm going to go to, and it's updated my PLC tag table. There you go. It's in there. So then I'm going to grab that guy. Because Portal pushes you to use 2 monitors. I'm going to come here, go to the main OB, and then I'm going to just grab a normally open contact, drag it on, drop it, put it in. There we go. And then I'm going to grab selector switch and drop that right there, and grab green LED and drop that right there. And then close that out and compile. And everybody's happy. I'm going to download and say yes. Okay. And then I'm going to go online. All right. So it's waiting for me to, and I switch that. And there you go. And if you want to see my screen there, Shawn, that's the green light is turned on.
Yeah, let me switch over to bring up your, all right, and could you switch it back off now?
Yeah, no problem.
Yep.
So there we go. We switch it off, we switch it on. Now I want to show you something kind of cool. If I turn that off, and I come back here, and I go offline, I have an indicator light that needs to flash to let the operator know that there's something here I need you to attend to. So we used to put in some type of timer, right? And so what we would do here, instead of that, I'm going to come back down here to my tab and go to the hardware config. I'm going to double click here. I'm going to go to module parameters, and I'm going to drop this down, and I'm going to put it at 2 hertz. Also, just to point out, I can also do a normally open contact and a normally closed contact and switch them. You see right here.
Cool.
And I can control the brightness of the LED if it has an LED. And it's all hard coded into it. So once I've done that, do a quick compile. I've always compile and then do download. So we're going to download that and hit load and finish.
Okay.
Here we go. Turn that on. And now it's flashing.
That's great. So you have a timer built in. So if you need the flash, you don't have to go get a clock bit or create your own timer. Plus, if it's a button, you can change the contacts from normally open to normally closed. That is very cool.
Yep. And that is Profinet push buttons. As I stated, let me quickly pull that up. Remember, you pointed out just a few minutes ago, here is the wiring diagram for that. So here's the back of that with the terminal blocks. And you come down here and it shows you that you just wire in that variable resistor or a potentiometer, and you see M, and there's the 10 volts, and then the signal comes into A, and then that guy is right here.
Excellent.
So if you come here, you go to properties and IO tags, and it comes in on I64 as an input and IO tags, and then I could call that a pot.
Yeah.
And now you have a potentiometer that you can use as a speed reference for your VFD.
That is very cool.
Engineering efficiency, we reduced wiring. We don't have all the IO cards that is required. And we have the diagnostics. Emphasize that each of these here, their names, you can change those if you would like, because this is your diagnostic string. So if something goes wrong here, then it would come up and say commanding. So you can double click here, and we go here to general, and it would say commanding and underscore LED module 2, or you can call that start conveyor PB. And then that would change this. Now see that it's changed it. This would be your diagnostic string to let you know if that button got damaged or is not working properly.
I wanted to ask you too, if I had, let's say I needed 2 potentiometers on the front of the enclosure, could I put another interface module in the system? Even if it didn't have any push buttons on it or pilot lights on it, could I just put it in there to grab some more IO?
Yep. Yes, sir. I have a customer that he uses these as small little IO blocks.
Yeah, I mean, if you just needed a second pot, it might make sense to buy another interface module and bring it into that than buying an analog card, right? Assuming the resolution and everything was correct for your application. But that's very cool. It really goes in line with all the videos we've done recently, looking at ET200 IO, all the different flavors and types, and what you walk through here. I'm just so especially thankful that it reads in all the push buttons and their positions and pilot lights, because if you have this on your desk, you're doing your first project, you can save a lot of dragging and dropping and searching through the hardware catalog just by reading it in, just like we can read in a rack of like ET200 SPIO.
Yep. Engineering efficiency, reducing wiring, reducing time in front of the PC to get things up and running. You saw how quickly just a simple push button and again, a simple start and turn that on, and off to the races we went.
Well, Mark, I really want to thank you. Was there anything else that we wanted to cover before we close out the show?
No, that's about it. I think we've got a little bit to have your viewers think about for it. So I appreciate the time, and I really appreciate you allowing me to show this. I think this is a really engineering efficiency way of going about using our push buttons and making everybody's projects in a timely manner and getting everything done and having cost savings with it.
Well, and I want to thank you for taking the time out of your busy day, not only to put together a little demo like you have for me to use here in the school, but also to come on and show our audience how to use this. And I want to thank our audience. This was actually prompted from one of you guys out there at calling in, writing in, I think it was on YouTube somewhere, and saying, hey, could you cover the Profinet push buttons from Siemens? And I didn't even know they had them. So thanks to the viewers out there for your feedback. That helps guide me on what you want to see. And Mark, this would not be possible if it wasn't for your expertise. Thank you for coming back on the show. I really appreciate it.
Thank you, Shawn. All the best. Thank you.
Well, I hope you enjoyed that episode. And I want to thank Mark for taking time out of his busy schedule to put together that demo and presentation for us and really bring us up to speed on SIRIUS ACT. And I want to thank the user out there who put a comment on one of my previous videos that said, hey, did you know Siemens has this? Because I wouldn't have known that unless you said that. So thank you to all you. I try to read the comments every day or at least every 2 days. And so I appreciate you all, wherever you are, whether you're on YouTube, the Automation blog, Spotify, iTunes, Google Podcasts, and wherever you're listening to this. I just want to thank you for tuning in. And now, with next week being Thanksgiving, we'll have a pause in the automation show. Then we have some more shows in December, and we're already filming episodes for next year. So I'm looking forward to releasing all those for you. And if you didn't know, I also do another podcast called The History of Automation. Right now, it's only available on video platforms, so YouTube, LinkedIn, and the automation blog. Hopefully someday we'll also do it on audio as well. But we're meeting with some of the really legends in automation who worked on some of the really, just really original PLCs, original HMIs, up and through like more modern day systems. So it's just been a blast having these folks on to talk about the history of automation. And so if you need something to listen to during Thanksgiving week or maybe during the holidays, check out the history of automation. Again, right now it's only available on YouTube, the automation blog, and LinkedIn. But I think you guys will enjoy that. And I want to wish you guys, since I won't be back next week, a very happy Thanksgiving. I want to thank you always for tuning in and listening. And I also want to wish you all good health and happiness. And until next time, my friends, peace.